Hello guys, good morning. Welcome to the session today. Hope you all are doing good. 1 minute.
Yes, sir.
Okay. So last time we learned about cloud storage, and after that we have seen what is a cloud SQL also, right? So what is a cloud SQL? Cloud SQL is a fully managed RDBMS solution available in the Google Cloud platform. So from today onwards, we are going to learn about BigQuery. Okay, what is BigQuery? Let us try to understand, and then we will try to practice what we can do with the BigQuery. Okay, so you have learned about Cloud SQL, right? Cloud SQL is used as a operational database, or you can think of like a OLTP, or you can also call as a RDBMS solution. Okay, so it can be used as an operational database. Like you can think of like an application is running. If you wanted to store the data that is coming from that application, you can use the Cloud SQL as a backend. So for sorry, so what is a Cloud SQL is that? Cloud SQL is a one of the RDBMS solution or a OLTP solution where if you think that one of the application is running or a web service is running, that data can be stored in the Cloud SQL. Okay, but sir, I wanted to store all the data of entire enterprise data into a data warehouse solution. So that's where the BigQuery is. BigQuery is a one of the data warehouse solution available in the GCP. Okay, so that means whatever the data that the company is holding, all the data can be stored in the BigQuery, entire enterprise data. For example, you can think of like this. So this is you can operational database or a transactional database. Call it as a transactional. Okay, so for example, if my business is running from last 15 days, think that like this. Okay, so assume that you have an application, a Flipkart application you can think of. Flipkart will be used by many people every day. Plenty of the people are interacting with the Flipkart application, and whenever someone is interacting with an application, the data will be generated. The data will be stored in the OLTP. OLTP is nothing but an online transactional processing. And one of the example for the online transactional processing is MySQL, SQL Server, PostgreSQL. One of the solution for the OLTP is MySQL, SQL Server, PostgreSQL. So these things are on premises. So some people are unable to manage this one. So that's the reason Cloud SQL was designed. Cloud SQL is also the same thing. It provides you the three database engines where you can able to work with this one. So whenever the data is generated at the application now, it will be moved to OLTP for the transactional database for storage purpose. So only transactional data will be available here. Only transactional data. Means for example, if the Flipkart is running from last 15 years, okay, last 15 years, OLTP cannot withstand all the 15 years data, cannot store all the 15 years data. So it will only be storing the transactional data. You can think of like a last 6 months data. Only last 6 months data will be stored here. But what about the 14.5 years of data? What about the 14.5 years of data? That 14.5 years of data will be moved to data warehouse. Okay, so here we are going to have a historical data. All 15 years data will be available here. Okay, so one of the solution for data warehouse is Hive. In Google Cloud Platform, one of the solution is BigQuery. This is on-prem, this is cloud. Okay, so this is how it happens in the real world. Okay, so whenever some application is running, some web service is running, due to the people are due to the traffic that the people are using that application or interacting with the application, the data will be generated. Data will be generated. That data will be stored in the transactional database. Either it can be a MySQL database or a SQL Server database or a PostgreSQL database. Okay. OLTP does not store the entire data because OLTP is not designed to store the data. OLTP is mainly designed to support the databases. It is acting as a backend for the application. Okay. So only last month, only the transactional data will be stored here. Only transactional data will be stored here. What are the examples for the OLTP systems or a RDBMS solution? MySQL, SQL Server, PostgreSQL. These are all on-premises services. These are all on-premises softwares, DBMS you can think of. But people are unable to manage their infrastructure, unable to manage their management details, unable to manage their networking. That's where the Cloud SQL is designed. And Cloud SQL is offering you three database engines that we have seen. Now the transactional database is only storing the data of last 6 months. What is happening for the last 15 years data then? Okay, so assume like this. If the Flipkart is started, think that this is just now it is 2012. Now we are in 2012. Flipkart just started its business. Okay, it's 1 month, 2 month, 3 months, fourth month, fifth month, 6 months. All the 6 months data will be moved to the data warehouse. Again, 1 year completed. Last 1 year data will be moved to the data warehouse. So only last 6 months data will be there in the OLTP, and entire 1 year data will be moved to the data warehouse. Again, second year, only the last 6 months data will be available in the OLTP. All 1.5 years data will be moved to the data warehouse. Third year, fourth year, fifth year, 15 years. Only last 6 months data will be stored in the OLTP. Entire 14.5 years of data will be moved to the data warehouse. Last 6 months data is the hard data or a fresh data or a transactional data. 15 years data will be a historical data. No transactions will be applied on that. It will be just for the storage purpose. Why we need to store this historical data? Can anyone tell me why we need to store this historical data? Data retrieval, no? Sorry? Correct. 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 So this is what the business think that. This is what the business decision makers think that historical data is something which is data is nothing but a money. What they think is that, see, if they wanted to come up with a one kind of a decision, or if they wanted to improve their business, if they wanted to improve their customer satisfaction, or if they wanted to improve the sales, or if they, you can think of like a big billions day, how it has come big billions day, or you can think of Amazon sales. So there was a sale happening, right? All of these things comes from this data warehouse analysis only. Okay, what they think is that whenever they try to understand the customer behavior, or if they try to understand the sales trend, they will be able to take a one more decision. So that's the reason. So all the historical data, it is not a simple data. You can think of like some terabytes of the data they are trying to store it here, which is very, very costly. Data is not just costly. Maintaining a solution is costly. Managing the solution is costly. Taking care of all the tables, refreshing everything, and recruiting the people to who can be doing this analysis and maintaining this data, reporting purpose, everything. There's a plenty of the money that the business is putting to store this historical data. And those are the companies now in the trend who has stored this historical data and used that data as an analysis purpose, and those analysis done is properly, whoever those companies are there, right? Those companies are there in the business trend now. Okay, who have used this historical data properly and who have taken a proper decisions from the business, those are the companies now in a very good situation. And those who have deleted the historical data, they didn't think about this is not a proper way of I mean, we don't need that historical data, who have deleted that data, right? Those companies are not in a good trend now. Okay, so that is the reason most of the companies, whoever is having the data and they're storing it properly, they're doing analysis on top of it. And once the analysis is done, they're going to be taking the business decisions on top of it. So one of the solution for the data warehouse is BigQuery. And what we are going to store, what we are going to do in the BigQuery, we first store the data here, and then we transform the data here, and then we analyze the data here. Okay, so BigQuery is where you can collect the data from some platforms also. Okay, BigQuery is a solution where you are going to collect the data, store the data, transform the data, and analyze the data. And one more advantage with the BigQuery that you can get is that BigQuery is a serverless platform. What is mean by serverless, sir? You don't need to create the server also. If you remember about the Cloud SQL, what were you doing? If you remember about the Cloud SQL, if you wanted to use the Cloud SQL, what were you doing? If you remember, you were creating a server. What was that server? You call that as an instance, right? You create an instance and only you will be working. Server or an instance. A server is nothing but a machine. a feature, an infrastructure you are creating. If you wanted to use the Cloud SQL, you are creating a server, you are creating an instance to work with it. But BigQuery is serverless. BigQuery is serverless. You don't need to create the server at all. But who will be creating a server, sir? Server will be created by the Google Cloud provider itself. You don't need to be worrying about it. Okay, Google BigQuery is one of the serverless service available in the GCP, whose entire server maintenance will be taken care by the Google Cloud platform itself. If for us, it is serverless. And what we can do with the BigQuery, sir? We can collect the data, we can store the data, we can process the data, we can analyze the data, and we can create machine learning models on top of the data. So that is also there. We can also create a machine learning model. So that's the beauty of the with the simple SQL. Okay, what language we are going to use, sir? Here, BigQuery is capable of running SQL queries. It comes up with a SQL query engine, and it provides you the very simple user interface to run your queries. Okay, it comes up with a very simple SQL query engine. With the help of the SQL query engine, you can able to run your queries. You can create tables, you can create views, you can create functions, you can create stored procedures, you can create machine learning models. Everything you can create it with the help of the SQL only. Okay, and BigQuery, with the help of the BigQuery. So if you go to Hive, what the people do is that to improve the performance, to improve the read performance in the Hive, people were using the indexes. Okay, people will be using the indexes to improve the performance. But in Google BigQuery, you do not have any concept of indexes. You get a very good performance here. The performance will be default by high. Very good performance you get here. Okay, you don't need to create any infrastructure. You don't need to create any indexes. No indexes, no infrastructure. Okay, so that's what it is. Without creating the infrastructure, without creating the indexes itself, you get a very good performance. You can think of like you can run terabytes of the data in minutes only. Okay, so you can able to just, if you wanted to process terabytes of the data also, it is a matter of, okay, so that's how your performance will be very high. Okay, so this is all about the BigQuery. Let me go to the BigQuery and show you how it looks like. I'm entering into the Google Cloud platform, selected the project. You can see here BigQuery data warehouse or analytics purpose. This is how the interface looks like. This is how the interface looks like. Very simple and easy interface. Even people coming from after graduation also, they can easily learn the BigQuery and they can create a tables and create analysis reports as well here. Very simple user interface. Everyone can able to understand easily. Okay, the hierarchy of these tables will be like this. The hierarchy will be like this. 1 minute. So you can see here what is a BigQuery. BigQuery is a modern data warehouse, serverless platform, highly scalable. If you wanted to work with a large amounts of the data, you can able to work with. The data in the BigQuery will be in the form of a tabular format. BigQuery comes up with a SQL query engine, which is capable of running SQL queries, and the performance will be very high. You don't need to create any indexes. You don't need to manage any infrastructure. And this we will see. Storage method. So BigQuery actually stores the data in the form of a columns, and traditional warehouses stores the data in the form of a rows. Okay. And the best thing about the BigQuery is, this is the best thing. If you go to the Hive, it only provides you the batch data analytics. Batch data processing, batch data analytics only it will provide you. But with the BigQuery, it provides you real-time analytics. BigQuery provides you real-time analytics, sir. That means streaming data you can insert into the BigQuery also. Okay, that's how the beauty of the BigQuery is. Streaming data can also be inserted into the BigQuery, and it supports streaming data analytics. You can write a query on top of it on the go. So that's how it is. Very beautiful point it is. And if you wanted to work with the BigQuery, so this is how the hierarchy is. This is how the hierarchy is. Well, not this one. Don't worry about it. So this is how the hierarchy is. The project ID is missed. Okay. So you can think of like this. Okay, you will be having a project. You see here GCP batch morning, GCP morning is your project ID. See, this is my project ID. So you will be having a project ID here. Under the project ID, you will be having a data set. I do not have any data set. So that's the reason I don't see any data set. Under the data set, you can create tables, or you can create views, or you can create machine learning models, or stored procedures, or some other things also. Okay, so under the data set only you will be able to create some objects like tables, views, models. Okay, so you can create any number of data sets. All the data sets will be under project ID. Project ID, you can see, and under the project ID you can have a data set. Sir, if I wanted to create a data set, what I have to do? So if you wanted to create a data set, the data sets are coming under the project ID. You go to project ID. This is your project ID. Click on these three dots. Click on these three dots. You see here, create a data set. Click on it. Provide the data set ID. Sir, my data set, I wanted it to be landing data set. Okay, landing data set. You can select the region, multi-regional. I am not selecting anything. Click on create data set. The data set name, location type, create data set. Okay, you see here, we have successfully created one data set, that is landing. Under the landing, do we have any tables? No. We have just created a data set. You see here, this is a symbol for the data set. Okay, this is your data set. Under the data set, if you wanted to create a tables or something, you can create it. So project ID, data set, and this is the hierarchy, don't confuse. And whenever you are using, whenever you wanted to use, okay, so your project ID will be there. Under the project ID, you have a data set. Under the data set, you will be having a tables. Okay, usually, whenever we wanted to create a table, so assume that I wanted to create a table. We will be using this one, right? The script, the SQL query will be like this. Create a table. I'll be mentioning some sales, okay, some employees table. Okay, employee and ID. Sorry, ID is integer into 64. Name string salary, float, and date of birth, date, and date of joining, timestamp, and marital status. Marital status, boolean into string of flow to date to timestamp boolean, and any other things we commonly use, date, timestamp, boolean. Any data type we commonly use, guys? I just wanted to cover all the data types in one table so that it will be easy for you to later use it. Okay. So string, integer, boolean. Okay. I think this is it. Okay. So if you wanted to create a table, this is how you will be doing it. Right? So you see here, you have just used a table name. But where this table will go? You wanted to create a table called employee. Okay, you wanted to just create a table called employee, but where the table will go? You can also see here somewhere it is throwing an error. You see, table employee must be qualified with the data set. See, it is telling you that you cannot just create a table and you can't create a table without referencing any data set, because the table will be maybe under some data set. So if you wanted to create any table, it will be referenced by some data set. So that's the reason whenever you wanted to create a table, follow this nomenclature. So you can't just give a table name. Instead, you are using over the internet, try to use the directory, table ID directory. So project ID dot dataset name dot table name. Okay, project ID dot. So project ID dot means, instead of just writing like this, project ID dot means GCP project ID dot dataset dot table name you wanted to mention, right? So employee. Okay, this is how you mention it. Okay, project ID dot table. Sorry. Okay, project ID dot. This is your project ID. This is your data set. This is your table. So this is the best way of using it. You see here, the query will process 0 bytes when run. See, whenever you are writing some query, and you always look at here, because it's going to be telling you how many bytes it is going to be processing, because whatever the bytes it is going to processing, it is be directly connected with the money. Okay, it is directly cost. So the cost of the query is totally mentioned with the help of the bytes only. So if something is taking a lot of bytes, it's going to be taking a lot of, it is going to be taking a lot of time and a lot of money also wasted. Try to tune your query accordingly always. Look at the query, look, write your query. If your query is good, and if you are facing any issues in the query, it's going to be telling you, this is a smart analytics. So it's going to tell you whether your query is correct or not. It's going to tell you if the query is correct, and it's going to tell you how many bytes it is going to be processing. Okay, so it is a smart analytics tool where you will be able to see the issues with the query or the number of bytes will process for the query. Okay, and sir, I have written a query like this to create a table. Okay, sir, you see here GCP hyphen batch hyphen morning. So I'm mentioning this is my, but looking at this, it is actually, this is easy to understand. But when you are joining, right, when you are joining some 5 tables, you may confuse that what is this one, what is this one. So to highlight the table ID separately, you can use this backcoat. You can use backcoat. Okay, you can use backcoat, start and end. If you use backcoat, it will be the table ID will be highlighted properly. Okay, so whenever you are using the table ID, you have to use backcoat to see visually. If you wanted to separate your table ID, or visually you wanted to get to know this is your table name, table ID, or something. So okay, so you can use backcoat. Where this backcoat will be available, sir? Below your escape button. Okay, so if you go to your keyboard will be like this, right? Okay, the very first escape you will be having, this is escape. Below that you will be having one backcoat. This is your backcoat, and beside one here, 1 2 3 4 will be there, right? So this is your backcoat, this is your escape button. Okay, this is escape button. Below the escape button, left side of your key one, keypad one. So this is your escape in your this one. So all of the all of those keys will be available here. Okay, so remember this one, which is very useful for you guys. Some people say, sir, where is this backcoat? I am unable to get it. Some people write it as a colon. Okay, some people also write like this. This is a colon. Sir, I have written everything good and it is very good, sir, but still throwing an error, sir. So it is they are not using the backcoat, they are using actually the colon, not colon. We can say what is this one? Quote, single quote. They will be using the single quote. I am saying that, sir, I have given a properly, but still it is showing. See here, we never use the quotes. We never use the quotes for the table reference. Always use backquote. Always use backquote. Okay. So this is how you can able to create a table. Okay, so creating a table, that means where this table will be created under this data set. Under the left side, you see here, guys, under the landing, you will be creating a table. Okay, let me just click on create, run. See here, left side, look at it, guys. Left side, look at it. Where the table is created, landing. Under the landing data set, you have created a table. And click on the table. When you click on the table, how many columns you have given? ID, name, salary, date of birth, date of joining. Almost all the database data types that we commonly use. All the data types that we commonly use, I have covered here. Mostly we will be using these things only. Integer, string, float, date, timestamp, boolean. Okay. Okay. So you see here, I have mentioned, you can able to see, once you click on the table, you will be able to see the schema. The first field is schema. Okay, first field is schema, next is details, next is preview. So these are the three commonly used fields. In the schema, you will be able to see list of all the fields, data types, and more. And in the details, you'll be able to see what is the table ID. So sometimes tomorrow you wanted to run select stars from this particular table. You don't need to write, sir, the project ID do I have to write and the dot landing. You don't need to actually write it. All the table is available, right? You can go to this table ID. You can just click on this copy button, or you can just click on this entire thing. Or you have a copy button here. Click on this copy button. Come here. Use the backcoat. Complete the backcoat. Okay, you see here. This is how it is. You can run it. Okay, it does not have any data because we have not inserted any data. Okay, so this is how it is. Okay, and after that, once you can see the data, when it is created, when it is last modified, all of the totals are over here. Number of rows, the number of bytes, you will be able to see. The number of rows are 0, the number of bytes also are 0 because there are no records inserted. Okay, so let us try to insert the data also. Let us try to insert the data also. So you already know, guys. Now tell me how to do that, how to insert the data. You guys speak up. How to insert the data. I wanted to insert data. Tell me, guys, how to insert the data. Correct. Insert into table name. My table name is employee and values, and I'm gonna insert it like this. Okay, the data I'm going to insert is, I'm gonna insert like this. Okay, one of the record I have inserted, sir. Okay, okay. Now tell me what is the problem. We have not mentioned the data set here. Okay, you can't just use the employee table. You go to the table. Yes, you go to the table, you get the table ID, copy this one, come here and paste it here. Okay, it will be pasted like this, but it will not visually correct. It will be correct. The query will be correct, but I wanted to separate it visually. I'll use backcode. See here how beautiful it is. And I have added one record, right? So I'm gonna adding. So you see here for the integer, I'm gonna mention. Okay, you can see here separately also. I'm going to keep this table on the right side. You can also keep the table on the right side for your purpose only to understand the schema. So for the integers, I don't need to use the backcode. For the string, we will be using the backcode. Whenever we wanted to insert the data of the string, we will be using the backcode. For the float, you don't need to use the backcode. You can use decimals also. For the data of date, for the date, you have to mention the year, month, date. Year, month, date. Okay, year, month, date. Don't forget. That's what it is. DD. Okay, you wanted to mention no. BigQuery does not store the data like that. Okay, so you cannot store. I mean, if you wanted to convert this as a string and you wanted to store it, that's for up to you. But if you wanted to store the date format, okay, if you want this particular column to be the date, you can use it like this. Okay, so you can think of like this. For one of the guy, I will give the name as this one. It will take it because it's also a string. And here you wanted to mention DD 13 5 1998. Okay, you can give that name. That's fine. That's perfectly fine. Okay, but the thing is that whenever this is your date column, you see here date of birth is your date column. Date of birth will always start from the year, month, date. Okay, y hyphen hyphen dd. Okay, so year, month, date. That's you have to follow. For the timestamp, also the same thing. Year, month, date. Year, month, date, and the time. Time is like hours, minutes, seconds. Okay, timestamp is nothing but hours, minutes, seconds. Where no, you cannot use slash also. Okay, let's try it out. It's not throwing an error. Okay, so you can't use slash. Okay, so this is the date format. For sure, we have to follow it. So I'm gonna go and change it. This name. Okay. Okay. So one is an integer. John Doe is a string. This is a float. This is a date. This is a timestamp. This is a boolean. Whether it is he is married or not. So likewise, I'm going to insert a few more records also. Okay, perfect. So we have like 4 records. 1, 2, 3, 4. John Day, James Smith, Bob Johnson, Alice Brown. Their salaries, their date of birth, their date of joining, their marital status. Okay, so once you have properly mentioned, click on run. See here how many records were added? 4 rows to added to the employee. If you wanted to go, and you have a query here, select star from landing.employee. You can run it here. Close this. You're supposed to see 4 records. It will be very fast, but my due to my internet connection or something. Okay. See here, we have like ID, name, salary, date of birth, date of joining, marital status. So that is how you will be able to see the data. And now I wanted to see the entire table also. Sir, I don't want it to run. See, to view the data, to preview the data, you don't need to run a query. Okay, because when you go to employee table, this is schema fields, this is details. You will be able to see the number of records are here, the logical bytes also here. Number of rows are 4. To preview the data, you have a preview option, click on it. This is free. When you click on preview and you see the data, it is free. You don't, so whenever you write a query and running the query, it is cost. Okay, so the bytes will be processed. There will be few bytes will be processed. You see here somewhere the few bytes will be built. Okay, so whenever few bytes will be built, there will be a cost associated. But when you are previewing the data, the cost will not be there. Okay, so ID, name, salary, date of birth, data journey, marital status. So this is how you will be able to see the data. Okay. Yeah. So this is about BigQuery, sir. We will be seeing few more concepts tomorrow. Okay. Yeah. So this is one way of creating your table. Let me tell you one more way of creating table. This is one way of creating a table from the script and inserting the data from the script. Okay. Now assume that I have some CSV file. I have some CSV files, sir. I wanted to load the data from the CSV file. I wanted to first create the table and I wanted to load the data into the BigQuery from that CSV file. Okay. So I wanted to create a table like that. How I can do that, sir? Okay. To do that, you can actually create a table from the interface as well. Click on this landing. When you click on these 3 dots, you will be able to see create a table option. Click on this create table option. Once you click on the create table option, you have here source. Do you want it to create an empty table? If you wanted to create an empty table, just click on the table and provide the schema. Just click on create table. If you wanted to create a table by loading some data, if you wanted to create a table from by loading some data, see here, I'm going to open some file. See, I have here customer file, customers table I'm going to create. Customer ID, name, address, city, state, zip, phone, email. So for these many of the columns are there. I'm going to copy these columns. And I have this file on my local machine. I have this file on my local machine. I wanted to load this data from this particular file to BigQuery as a table. Okay, so I'm going to click on this upload. I'm going to select the file. Where is that particular file? Is browse, desktop, customers. See customers.csv, uploading it from the local machine. What is the file format? BigQuery supports 5 file formats. BigQuery supports 5 file formats. CSV. CSV are text files or Excel files, all are same, sir. Don't worry. Okay, CSV, text, Excel, whether the text files are allowed or not, yes. Whether the Excel files are allowed or not, yes. Don't worry about it. CSV, text, as well as Excel files are same. JSON means JavaScript object notation. Avro files, Parquet files, ORC files. Avro, Parquet, ORC are the big data formats to store the data in a very optimized manner. Okay, so you can go to Avro, Parquet, ORC. CSV is commonly heavily used. JSON is JavaScript object notation, nothing but a key value pairs. Avro, Parquet, ORC. Don't forget it. They're going to be asking in the interview what are the file formats that the BigQuery is supporting. BigQuery supports 5 file formats: CSV, JSON, Avro, Parquet, ORC. I'm going to select, because my file is CSV, I'm going to select CSV only. After that, project, always whenever you are creating a table, select the project ID, select the data set, select the table name. The table name I am going to give as customers. Where this table and created, sir, this table will be created under this landing, under this project. Okay, and here table type. Table type, there are two types of tables. There are two types of tables. In the BigQuery, we have two types of tables. One is in BigQuery, we have two types of tables. One is native table. One more is external table. BigQuery has two types of tables. One is native table. One more is BigQuery table. Native table is very simple. The name itself, it is telling you native. Native means it will be available in the BigQuery. That means the schema fields plus data, both are available in the BigQuery, is nothing but a native table. Schema, nothing but the relationship between the columns and rows, nothing but a column name, comma, you already seen, right? Table structure. So schema plus data, both are available in the BigQuery, then that is called as a native table. External table means external. Only the schema will be there in the BigQuery, but data will be there in some other platforms. Some other platforms. Data will be there in some other platforms. That means data will not be there in the BigQuery. Only schema will be, only table structure will be there in the BigQuery. The data will be there in the Google Cloud Storage, or the data can be there in the Azure Blob Storages, or the data can be there in the AWS platform. Okay. So it can be, data can be there in any other storage layer. Okay. So that is what is the external tables. You can run queries on native tables also. You can run queries on external tables also. Which is faster? Guys, which is faster? Which query will be faster? External query will be faster, or native table will be faster? Correct. So native tables are very faster because schema as well as data. Why? Because BigQuery will be optimizing its data storage. BigQuery will be optimizing its data storage. As I was telling you, BigQuery stores the data in the form of a columns. Columnar storage is very, very, very very easy or important or very faster whenever you wanted to run queries. Whenever you wanted to run queries, it will be very faster, columnar storage. But when you are going for the GCS, it stores the data in the form of objects. GCS, Azure, or AWS, the data will be stored in the form of objects. Okay, understanding the object data and uh, their own storage model is different. So running the queries in the external is little bit slower comparatively. This is higher, this is slower. Okay, so that is what is the difference between the native and external table? Native table, the schema plus. This is a question, sir, in the interviews. This is a question. That's the reason I'm telling you. Otherwise, why would I tell? It's a question in the interview saying that what is the difference? What are the table form? What are the table types in the BigQuery? You say that there are two types of the tables in the BigQuery. One is native table, one more is external table. When I say a native table, the both the schema as well as the data will be available in the native. So the queries are very faster. And external table, the data will be there in the other platforms like Google Cloud Storage, Azure, or AWS, but the schema will be available in the BigQuery only. We can still run the queries on these tables also, but the query speed will be comparatively less. Okay, that is what you will say. Okay, yeah. Now, as I was selecting upload button, that's the reason you only see a native table. But if I select Google Cloud Storage, you will be able to see two options, native, external. If I select Azure also, you will be able to, AWS also, you will be able to see. Okay, it is directly selecting this one. Okay, external path. Because we are, that Google Cloud Storage is our native service. That's the reason it is asking. So you can select like this. So whatever the option you wanted to, you can select a drive, external table. Okay, now I don't want it to create an external, I wanted to select upload, or if your file is there in the Google Cloud Storage, it's your choice. You wanted to go external, you wanted to go native, it's your choice. But now I'm with the upload button. I have my file. I have my file in my laptop, local machine. I've selected the file, selected the format, given the table name, selected the table type. Now this is a situation where we have to provide the schema. Okay, either you can add like this, any number of fields you can add it. Okay, you can add like customer ID, all of those things, or you can also do one thing. Don't never ever auto detect the schema. Okay, never ever auto detect the schema. Let me quit it and try to detect. This error will go away. I don't know why it is coming. Let me refresh it. Okay, under the project ID, under the landing data set, I wanted to create a table. Click on create table and upload. Select the file, customers, table name is customers, native table selected, and you can add fields like this, or you can click on edit as a text, paste the schema, customer ID, name, address, city, state, all the comma separated files. Okay, click on again edit as a text, unedit it, automatically schema will come. Customer ID, I don't want it to be a string, I want it to be a, you see here, I want it to be an integer. You can select the, you can see here all the data types, string, bytes, integer, float, numeric. I'm going with the integer. Field, name string, address string, city string, state string, zip code also, zip code I can be, it can be an integer, pin code, phone string, email string, because phone was comes up with a hyphens, guys. That's the reason I have mentioned it as a string. Okay, so perfect. I have selected all the fields. Okay, I am telling you either you can directly add it. So I'm removing it one more time. I'm telling you, some people will ask me. Okay, either you can add it like this. You can mention customer ID and select it. One more field, name. One more field, age, or whatever it is. You can do it like this, or you can click on edit as a text and paste it, and unedit as a text, unselect it. Automatically everything will come, change accordingly. change your schema accordingly. Okay, name, address, city, state, zip, phone number, email. Okay, so this is how I have selected the schema. Now this topic we will cover later. Just to create a table. Okay, wait a minute, I would have told you these options also. Okay, yeah, it is failed an error. Yes, good. See here, right if empty. This is also right preference also we should understand. Right preference is something, if the table is not created and you wanted to create it and load it, right if empty. You have a table, the data is already exist, you wanted to append it to the existing data, you can go to the append to table. If the table is already there, you wanted to overwrite the data, you can go to the overwrite table. Okay, so write if empty, append to the table, or overwrite the table. Okay, you have three options. Write if empty, when you will be writing that data to the table when the table is empty. Append to the table, if the data is existing, you wanted to append it. If the data is existing, you wanted to overwrite it. So these are the three options you can select. For now, write if empty, because my table is just now I'm creating it. It is a comma separated file, tab, pipe, custom. You can select my field delimiter is comma separated. Double quote character is double quote or single quote. You can also mention, that's also fine. You can mention anything, that's not at all a problem. Header rows to skip, which is very important. Header rows to skip. See, I have a header row. This is my data and this is my column names. So I have to skip one header, right? So header rows to skip is 1. Header rows to skip is 1 because I have a header in my file. So I have to skip this first row. Okay, so I say number of header rows to skip is 1. Now click on create table. See, now created a table. Okay, you can click on this customers table again. You have this one, customer ID, name, address, all of those things. You can go to the details pan. You see 5 records are there. Do I have 5 records? Yes, I have 5 records. And you can able to see the number of bytes. And when it is created, all of those things. If you wanted to preview the data, you can see here. Perfect. Customer ID, name, address, city, state, zip, phone number. Okay, so this is it for today, guys. So we have created employee table, customers table, employee table we created from the editor, customer table we have created from the console. Okay, query editor we have created it, and we using the console we have created the customers table. Okay, so these were two things that we have created. Okay, there is no enforcement here. There is no enforcement of primary keys and foreign keys. Okay, it doesn't support. BigQuery does not support. Yeah, there are many ways. You see here, I have created from the, that's the reason I told you. Okay, one is, that's what I'm telling you. See, one is using the query editor, and one more is from the console. Tomorrow I will also show you or tell you about the Cloud Shell using the big QLOAD command. So usually three methods. Okay, and if I have to extend it, many other ways we can actually do it. Many ways. I would say if someone is asking me in the interview that question, there are many ways that I can insert the data into the BigQuery. I can create a table on my own. I can create a table from the console. I can create a table, or I can insert the data from the Cloud Shell. I can insert the data from the data flow, data proc, data ETL tools. Many things are there. Okay, I can even insert the data from the Cloud Composer also. Okay, so there's no number. I would say there's no number for that. You say many number of ways, and you tell that, okay, I'll be doing this one, this one, this one. You can just name it like 4 or 5. Okay, yeah, commonly used is these things. Yeah. Okay, any other questions, guys? ETL and ELT are the pipelines, right? So that pipelines will be data prog, data flow pipelines you will be seeing here. Okay, any other questions, guys? Any other question related to the BigQuery? There isn't much difference. It's like this. You have it's a flavor of SQL only. Both are the flavors of SQL only. It's like this. You can think of like you know there will be a schema. The command difference will be there. That's it. Only for example, I'll be using if I go to MySQL, I'll be using the integer. Okay. If I use the string, I'll use string 200, string 300. Okay, something like that, where char I will be using for the data type. But in the standard SQL, I will use directly string. I don't need to mention the number of chars also. Okay, something like this. Those kind of changes will be there. But concept wise, every SQL is same. Only the commands wise, it will be difference will be there. If you wanted to look at the commands wise, you can actually go to the BigQuery SQL standard SQL introduction to SQL in BigQuery. You have a public documentation. You can always go here. Okay, so BQ. If you wanted to always, if you wanted to create a table, you can. But usually, it will be showing you 1 minute. Somewhere it will be showing you all the things if you wanted to create anything or data transfers or transport data. Put data to the cloud storage. No, not this one. BigQuery. Standard SQL. Okay, query syntax. Okay, you can actually check it. You have a plenty of the things here. You see. Okay, all the things are properly mentioned here. How do you use it? Select a distinct as well as all of those things, unnesting, nesting, inner joins, full outer joins, all of those things, group by classes. All of these things are available and which is exactly similar to the legacy SQL as well. Legacy SQL, we don't use it. Okay. In this, we will be in the BigQuery, we will be using the standard SQL only. People call it as a Google SQL also. All the things. And if you wanted to see the some of the transformation or string functions in BigQuery, you can also go and check it. So all of those things are properly documented. Whenever you wanted to use it, you can see concat, lower, list, tree plus, tree split. All of those things are also available here. So you can actually check. It's just the same thing. Whenever you wanted to use some function, you already know. And if that is the same function, you can directly use it. Usually, most of the times, it will be the same only. Split will be the same. Group by will be same. Having is same. And select is same. And where is same. So almost all the things will be there. But only the when it comes to the string operations, it will be little different. String operations. Okay. String functions. Okay. Those are a bit different. But all other things are same. Okay. Yeah. Okay. All right. Let's see tomorrow, guys. Thank you all.